Hi everyone, in part 3 of chapter 8 we'll be talking about the vertebral column and the thoracic cage, which is corresponding to section 8.3 in your anatomy and physiology textbook. So in this video we'll be talking about the general features of the vertebra and the types of vertebra that make up the vertebral column. We'll be talking about intervertebral discs and how they relate to the vertebra. We'll be talking about some of the specialized vertebra and where we find them in the vertebral column. And then we'll talk about the sternum and the rib cage and the anatomy of those two things. So you guys probably know some of this already. The spine is there to support your skull and to support your trunk, your torso, and to allow for movement of those things. Your spine, of course, protects your spinal cord. Your spine also absorbs stress, and that's where those intervertebral discs come in. And your spine also provides attachment for your pectoral girdle and your pelvic girdle, your shoulders and your hips, and allows movement of your limbs at those attachments. Typically, people have 33 vertebrae with discs between most of those vertebrae. The discs account for about 1/4 of the length, and the discs are able to compress when pressure is applied and then kind of bounce back when the pressure is alleviated. So this slide is really important. Make sure you know this one. This one is very important for your exam too. So we have 7 cervical vertebrae. These are our neck vertebrae. Okay, so 7 cervical vertebrae. The first 2 are specialized. The atlas, we call it C1, cervical vertebra 1, and the axis is C2. Okay, so we'll talk about C1 and C2 individually because they're very, very important. And then C3, C4, C5, C6, and C7. So those are your cervical vertebrae. Then we have 12 thoracic vertebrae. These are where your ribs attach. These are like your upper back from your shoulder to the end of your rib cage. So we have 12 of them, T1 through T12. And then most people have 5 lumbar vertebrae, but there is a little bit of individual variation here. About 1 in 20 people have an abnormal number of lumbar vertebrae. And people can have an abnormal number of other vertebrae too, but lumbar is the most likely place for that difference to occur. So we have 5 of those, 1, 2, 3, 4, 5. Then we have 5 fused sacral vertebrae. See, they're fused together here. They make this kind of complex that's going to articulate with the pelvis. And then we have 4 fused coccygeal or coccyx vertebrae. And these are your tailbone. They're the remnants of tails. So, cervical, in your neck, thoracic, where your ribs attach, lumbar, lower back, sacrum, associated with your pelvis, and coccyx, tailbone. Guys, I can't overstate how important this slide is. I think this is key to this whole chapter, and please expect to see at least a couple questions on exam 2 that come directly from this slide. So your spine is not a perfectly straight line when viewed from the side. Okay, so we have this natural curvature to the spine. We'll start by talking about an adult. We call this an S-curve. Okay, so there's a little bit of a curve in the thoracic vertebra, a little bit of curve, in the cervical vertebra, a little bit of curve the other direction in the thoracic vertebra, kind of a more pronounced curve in the lumbar vertebra, and then your sacral and coccyx vertebra curl the other way. So we have this S shape from the cervical to the thoracic to the lumbar to the sacral and coccyx. Now, in newborns, it's just a smooth C shape, and this changes as babies learn to crawl and walk. They get the more distinct adult type shape to their spine. So we have some different ways that we can have abnormalities in the spine. Okay, so one that we've probably all heard of is scoliosis. Scoliosis happens when we have an abnormal shape curve in the spine. Okay, so a lot of times this starts to show up in teenage girls. It does have a genetic component. If your parents have scoliosis, you may be more likely to have scoliosis. Poor posture can play a role, but really scoliosis is normally just there. It's a congenital thing. It's something people are born with that may become more severe with age. We talked about kyphosis in when we were talking about osteoporosis. So this is like a hunchback, an exaggerated curve in the thoracic vertebra here, associated with osteoporosis as the bones become less dense. And then lordosis is way back. So when we have pressure, kind of gravity pulling those lumbar vertebra forward, either during pregnancy or if a person is very overweight, we can see an exaggerated lumbar curve, and that can be pathological, causing pain or other problems. All right, so now we're going to talk about a vertebra in general. Okay, so there are some big differences between cervical vertebra, thoracic vertebra, lumbar vertebra, and we'll talk about those. But first, let's talk about a vertebra just in general. Okay, so the first thing is it has a body, and depending on what type of vertebra it is, the shape of the body can be different. Okay, but they all have a central area. So we have a body. We also have a vertebral foramina, and this is where the spinal cord passes through. Okay, a vertebral arch is kind of the area that makes the other portion of the vertebral foramen other than the body. So the vertebral arch is going to be this portion here. The rest of that foramen other than the body. Okay, the spinous process is the thing that goes towards the posterior. Transverse processes are the arms that go out towards the side. Superior articular processes, these are between the spinous and the transverse, and this is where one vertebra articulates with another. Okay, so those are right there. The facets on those superior articular processes are cartilage surfaces, the hyaline cartilage, and that cushions the articulation between vertebrae. And finally, the intervertebral foramen, we can see that here. This is where the vertebra come together, and when we see from the side, we can see kind of this opening from the side. Okay, so the vertebra fit together very closely. They fit like puzzle pieces. It looks like a very complex shape, and it is. But when we hold them together, they articulate with each other very smoothly in a healthy individual. So humans have 23 intervertebral discs. These are between the vertebra, and they provide cushioning and absorb shock. So each one of these discs has two parts. The first is the nucleus pulposus. Okay, so this is kind of a gelatin mass that's on the inside. And then the annulus fibrosus is outside of it, and it kind of is the tough exterior that keeps the gel substance inside. Okay, so if a person has what we call a herniated disc, we have an area of damage in the annulus fibrosus, and it's allowing that gel substance to kind of protrude outward, and that can put pressure on the spinal nerves. All right, so now we're going to talk about each type of vertebra separately. So we're going to start with the cervical vertebra. So these are up in your neck. There are 7 of them. 3, 4, 5, 6, and 7 are very similar. C1 and C2 are very individualized. So here is C1. I want you guys to know the name of this. C1 is the atlas vertebra. Its job is to support the head. This is the only vertebra that doesn't have a body. Okay, so it's got this kind of ring structure. It's a bit more delicate than some of the other vertebra, and that, when somebody has a broken neck or has an injury and injures their cervical vertebra, this one is more delicate than a lot of the others. The atlas joint is the one that allows you to nod your head up and down, yes or no. That's something I'd like you guys to know. It has, on the transverse processes, these foramen right here, and we have some nerves that are passing through those as well. C2 is the axis. I would like you guys to be able to remember that as well. So the axis allows you to turn your head back and forth, rotating as if you are indicating no. It has a specialized process called the dens. We see it right here. So the dens fuses here between ages 3 and 6. It's separate until, or at birth, and for a couple years there. And this dens is the thing that is projecting into C1, the atlas joint, and articulating there. The joint between C1, the atlas, and C2, the axis, is called the atlantoaxial joint. And this is what that joint looks like. It's hard to see a process in a still picture, but this is where we would turn our head, yes or no. We have the atlas, the C1, and the axis, C2. All right, moving on to the thoracic vertebra. So we have 12 thoracic vertebrae. They correspond to our 12 ribs, and there are attachments at each vertebra to a rib. Their body is larger than the cervical vertebra, but these are smaller than the lumbar vertebra, which are in the lower back. So we can see the large body. We can see the foramen magnum, where the spinal cord passes through, the spinous process, and the transverse processes. That spinal process kind of angles downward in the thoracic vertebra. All right, moving on to the lumbar vertebra. These are the ones in your lower back. Most people have 5. These ones are very stout and thick. The body takes up most of the space. We still have the spinous process and the transverse processes, and then the superior articular facet there. Here, the spinous process kind of trails down, but not nearly as much as it did in the thoracic vertebra. All right, so we're going to talk about the sacrum and the coccyx together because in adults they are very much fused. So here we have S1, S2, S3, S4, and S5. So these are our 5 fused sacral vertebra. And then we have coccyx 1, 2, 3, and 4. And this makes up our tailbone. So if you've ever heard of somebody falling, rollerblading and skateboarding are famous for this. Somebody falls real hard on their butt and they break their tailbone. They're breaking a portion of their spinal column, actually there. That's the coccyx. Coccyx can also be fractured during childbirth. Right, and we're going to wrap up here with a little bit of talk about the thoracic cage. So our thoracic cage is made of the thoracic vertebra. There are 12 of them. We already talked about them. The sternum, which is like your breastbone here in the front, and your ribs that reach all the way around. Okay, so the purpose of the thoracic cage is to protect the heart and the lungs. They also protect the spleen, the liver, and kidneys to some degree. The thoracic cage also is the place where the pectoral girdle attaches. Okay, so we have the scapula up here, and the scapula and the clavicles, they are the place where your humerus and your shoulders are going to attach. Your ribs have the ability to expand and contract, and this allows your lungs to expand as you breathe. So the sternum here in the front has 3 parts, and I'd like you to know these 3 parts. Okay, so up here where the clavicles, your collarbones, are attaching, and this is in the front of your body, so this T1 is like your vertebra in the back, and then your sternum is on the front of your chest. Okay, so your manubrium is the top part connecting to the clavicles. The body, also called the gladiolus, is where your 2nd, 3rd, 4th, 5th, and 6th, 7th, that cartilage for multiple ribs comes in to the body and the gladiolus. And then the xyloid process is the very end here. And the xyloid process is the thing we have to be careful of when we do CPR, because if we break the xyloid process, it could cause internal bleeding and end up being fatal, which would be very unfortunate. So our ribs are in 12 pairs. Okay, so we can look here. Coming in to the manubrium, we have rib 1, and then ribs 2, 3, 4, and 5 are coming into the body. Ribs 6, 7, 8, 9, and 10 all join together in the costal cartilage and also come into the body. And then we have rib 11 and rib 12 that don't make it all the way around to the front of the body. Okay, we'll talk about that in just a second. So the ribs attach at the thoracic vertebra, like we've talked about a couple times already. They have a head and a tubercle that articulates with the thoracic vertebra and the transverse process there. Okay, so the head articulates with the body of the thoracic vertebra, and the tubercle articulates with the transverse facet of the transverse process. Okay, so that's how the rib matches up with the thoracic vertebra. So we say that ribs 1 through 7, 1 all the way through 7, are true ribs because they are directly connected to the body, the gladiolus, of the sternum, or 1 is connected to the manubrium. Okay, so 1 through 7 have direct connections to the sternum. Ribs 8 through 12, 8 down through 12, we call those false ribs. Okay, so they don't have their own independent connection to the sternum. 8, 9, and 10 kind of join up with 6 and 7's cartilage, but they are not independently attached to the sternum. Then 11 and 12, they are false ribs and they are also floating ribs. They don't have any cartilage joining them to the sternum at all.